Hello everyone. Our group is Anjonghyun, Chaeyoungjun, Kim Donggun. Today we are going to present on the topic The Future of US Economic Growth, according to Fernald and Jones' paper. These are the table of contents, and we will now move on. Throughout the history, humans experienced a steady rise in living standards. In this article, we are trying to project how the next 25 to 50 years of American growth moves. As shown in the graph, US has had a steady 2% growth rate. Surprisingly, US's potential GDP and actual GDP is almost the same. Though there was a Great Depression, the effect was not permanent. However, if we look more closely, we can see that the growth rate from 50s decreased from that until 1929 by 0.2%, and in 1995, markedly, it fell to 1.82. Still, thanks to its near-perfect consistency, US outpaced the growth of UK in 1929. On the other hand, there are some examples that has high fluctuations. Opposed to the standard growth theory, which explains that financial crisis has no run effect on income per person, Japan experienced severe effect. These examples should always be kept in mind when projecting on growth rate of the future.
Thank you, Donggun. Now I would like to turn your attention towards a modified version of the semi-endogenous growth model proposed by Stanford economics professor Charles Jones, in which long-run growth arises from the discovery of new ideas, but is pinned down by the exogenous growth of population. This just means that population growth is an external factor to this model, which partially constrains economic growth based on ideas. In this modern growth model, the final output, or Y, depends on physical capital K, hours worked N, human capital per person H, and a stock of ideas. This model is represented in the equation listed. While traditional growth accounting calculates A as a residual, the theory of modern growth adds definition to that residual in terms of economic forces. For those of you who are still scratching your heads, a residual is defined as something that is left over after the main functions of a procedure are carried out. In the case of the traditional growth accounting models, the residual explanation of A implies that ideas are just a remainder of the share of economic growth already assumed by K and L, or factor accumulation, which has been proven to naturally decline as a country develops. On the contrary, the modern growth theory is something that embodies the key insight of former Nobel Prize winner Paul Romer, who explains how the non-rival characteristic of ideas, or A, leads to increasing returns to scale, or in other words, sustainable growth. As a result, income per person becomes dependent on the total number of ideas in an economy rather than ideas per person. This contrasts sharply with development models that are centered around capital accumulation and is more suitable for gauging the economic growth prospects of advanced nations that are investing heavily in R&D like the United States. In order to help conceptualize Romer's insight, the author of our topic paper depicts how adding one new tractor to the economy benefits one farmer, while adding one new idea potentially benefits everyone, regardless of the size of the economy, because the idea is not depleted with use. In this sense, there is no notion of scarcity when it comes to ideas. The modern model reflects how this concept of universality impacts the aggregate economic growth environment. So our model uses Romer's insight as a foundation, then adds Jones's element of population growth, pinning down this process to explain how infinitely sustainable growth is not truly feasible and that economic downturn will eventually befall on the US economy. In order to meticulously explain A's role in modern economic development, I turn your attention towards the idea production function. Here, R is the number of workers involved in R&D, and A portrays the output of ideas that are produced over time. The key takeaway here is that the output of ideas is proportional to the number of workers involved in R&D, which in turn is proportional to population in the long run. So the population of countries which are producing new ideas matters for idea-based economies because this is the primary driving force behind advanced stage economic development. Now, I want to ask you, what factor must be concurrent with population growth to guarantee the consistent efficiency of R and thus the production of ideas? Well, it's educational attainment, also known as human capital per person or quality of labor. And that leads us into the modern growth accounting theory. Here, education is reflected as H, along with three other factors that also contribute to economic growth in the modern era, including investment rate into research, denoted as R&D intensity, and also the number of people in an economy, or labor, and capital output ratio as implied in traditional models. As we can see in figure 2 percentage points of economic growth came from labor productivity, which largely derives from increases in research intensity and increases in educational attainment. While educational attainment has risen each year and it's the key driver for increasing H, this study undertaken by Golden and Cates, depicted in figure 3, shows how educational attainment in the United States is now showcasing a downturn, indicating that this factor of growth cannot grow forever, just as the fraction of the labor force working in R&D also cannot grow forever, strongly supporting Mr. Jones's theory. This inductively implies that while only H generates sustainable long-run growth, even this term could itself be declining as fertility rates are also slowing down. We do not know when this long-run phenomenon will be felt by the economy, but the central idea of the modern growth accounting theory implies that future growth might be much lower than over the past half century based on the downturn of all factors, including the generation of ideas.
Thank you, Jung-hyun. Now the question is, will growth actually slow down in the future or not? The accounting we are dealing with depends on two assumptions, which are the shape of the idea production function and the growth of inputs into research. Regarding the idea production function, the parameter gamma in figure 2 that was previously introduced is the production function for new ideas in the equation below, and restricting FA to be a power function is required for balanced growth. For example, the estimate of gamma equals 1 over 1 minus phi in figure 2 implies that historically phi has been less than 0. This means that as time goes by, new ideas are more difficult to discover because the important and easy ones have already been found, which is known as the fishing out argument. Similarly, some scholars claim that we may have cherry-picked the most easily discovered and important ideas, perhaps implying slower growth in the future. We can note that diminishing returns to the idea production function in the equation is consistent with balanced growth, even if phi is negative. This is possible because of the exponential growth in the number of researchers R. However, even if it is convenient to restrict FA to be the power function in this equation, it might not be realistic. Moreover, the shape of the FA in the past might not be a reliable guide to higher or future levels of A. This figure shows potential alternative paths. The idea production function of the past exhibit diminishing returns that support our argument of ideas becoming hard to discover. Alternatively, we could hit an inflection point, exhibited by the dotted blue line, that is trending in a positive direction, implying that ideas become easier to discover. Or this could be true for a while, and then we could hit a complete idea slump, represented by the purple curve. Another possibility could be that we have a wave of good and bad periods fluctuating over time. So these alternative paths imply the different possibilities and uncertainty of future economic growth. We also need to consider the growth in research inputs R. In the accounting, R has been growing faster than the population, which can't continue forever, which implies slower future growth. However, researchers could continue to grow for a long time, and new research technologies might allow capital K, or in other words, computers and robots, to replace labor. In this graph, it shows that South Korea, along with China, have been rapidly increasing its research and development expenditure. China, in particular, has a population of approximately 1.4 billion people, which means there is a possibility that the Chinese economy could contribute substantially to the future of technological progress compared to its contributions over the last 50 years. For reference, China produced almost no PhDs in science and engineering, but by 2010, they were producing around 25% more than the US. With this in mind, how many of the next Steve Jobs and Thomas Edisons are waiting to realize their potential? Furthermore, the development of AI and machine learning means that robots could increasingly replace human labor in the production function for goods. In standard growth models, this would lead to rising capital shares, and we see this to be true as many countries since around the 1980s have been enjoying rising growth rates. If we take this production function, for example, we can see that the more we are able to replace labor tasks with capital, capital share will rise.
So until now, there were some neoclassical approaches for growth projection. For example, taking account on semiconductor rise for future projection. However, these methods are highly narrow and local. Thus, this study views American growth in a more accurate and a broad perspective. There are 4 points the paper focused on when being studied. First of all, the study acknowledges that growth in educational attainment, R&D intensity, population will be lower in the future. Second, the rise of emerging economies in developing countries will cause increase in research, which is called the counterbalancing factor. Third, idea production has uncertainty such as the rapid growth of AI in human occupation. Last but not least, income inequality, climate change will cause systematic shifts in the growth. Similar to what we learned in trade policy classes, high percentage growth rate in the past will not persist forever. That's why we should project the future growth rate accurately and study upon the topic. Thank you for listening.